Hello everyone, welcome to Excellent Go Tutorials. Today we're going to be talking about indices. So basically questions are addressed here are questions from MTH101 of student that attend Federal University of Technology Owerri. So here are my contacts, you can reach out to me. Okay, coming back to indices, we have to understand what basic concept of indices is all about first before we think about solving questions on indices. Although in this video I'm not going to be solving questions, but I'll give questions and with their solution, then you can pause the video and look at them due to timing. So coming back to indices, we come to the introduction of indices. You can say that the arithmetic operation of raising to a power is derived from repetitive multiplication. Now, what is repetitive multiplication? It involves multiplying a number by itself. Multiplying a number by itself. For example, you have 10 times 10 equals to 10 raised to the power of 2, or 10 squared. So this 2 is showing that 10 is being multiplied by 10 again. You can have other examples. You can have a times a times a is equal to what? A raised to the power of what? 3. Showing that a is being multiplied into 3 places. So on formality, we can say if a number is written in index form, that is a raised to the power of n. A here is called the base and n is called the index. Knowing about base and this index will help you when solving questions so that you don't actually mix things up. So indices, which we have called the topic, is the plural form of index, talking about more than one, plural. So if you have something like this, you have we have 9 raised to the power of 3. Our 9 here is the a, our 3 here is the n. So we can say that 9 here is our base and 3 here is the power. Or you can call it the index. That is the indices we are talking about in this video. Another thing now is if you have something like 27 and you're asked to put 27 in index form, you know that 27 is equal to what? 3 times 3 times 3, which will give you what? 3 raised to the power of 3. This 3 raised to the power of 3 is showing now that I post 27 in index form. So the question now is how do I get mastery of this indices? So how do I gain mastery of indices? So in order to gain mastery of indices, you have to take note of these 3 steps. 1, you have to learn and memorize all the rules of indices. So this will be addressed in the next section. You have to study carefully and know the correct rule to apply in each case. So there are various rules. A question might require more than one rule to apply in the case. Then you have to take note of basic mathematics, which is our board maths. So you have to apply board maths in whatever mathematics you're solving so that you don't confuse yourself or confuse things. So in board maths, I'm going to show you something. If you have something such as 10 plus 10 times 2 minus 10, 10 plus 10 times 2 minus 10. So you have to take note of this so that you don't make mistake. Here now, you have board mass. What is board mass? Brackets of multiplication. B stands for brackets of, which is still multiplication, the right of if you are getting a question. Brackets of multiplication, of division, multiplication, addition, and what? Subtraction. So this is board mass. Looking at this question now, there's no brackets, there's no up, there's no division. What comes next? Multiplication. So if you're using multiplication, first of all you write this as 10 plus 10 times 2 is what you refer to. 10 times 2 to give you 20 minus 10. Then what comes next? Addition. So if you're adding, you have that 10 plus 20 is equal to what? 30. And 30 minus 10 minus 10 will give you 20. So 20 is what you should get from this now. Then take note of this second example. If you have 10 plus 10 all in brackets like this times 2 minus 10. First of all, you have to resolve what is in the bracket in board mass. That is 10 plus 10, 20. And you're having what? 20 times what? 2 minus what? 10. So it will be equal to what? 40 minus 10, which will give you what? 30. So this will give you 30. Then we'll go back to the rules of indices is what we'll be looking at next. So in the rules of indices we have about 8 rules here. The first is multiplication rule, where you have that a raised to the power of m times a raised to the power of n is equal to a raised to the power of m plus n, where you have x times x raised to the power of 2 times x raised to the power of 3 will give you x raised to the power of 2 plus 3, which is equal to x raised to the power of 5. That's what we treated initially, that we had 10 times 10 is equal to 10 raised to the power of 2. That is 10 raised to the power of what? 1 plus 1, which is equal to 10 raised to the power of 2. Then here you have x raised to the power of 1 times x to the power of 2 times x to the power of 3 is equal to x to the power of 1 plus 2 plus 3, which is equal to x raised to the power of 6. Then you have to note in the following: if the bases are not equal, here is 2 and here is 3. If they are not the same number, this rule cannot hold. And if you are having two powers that are the same, like 2 and 2, you don't add the bases. You don't ever add bases in indices because they are having the same power. Then look at the subtraction rule. It says that a raised to the power of m divided by a raised to the power of n is equal to what? A raised to the power of m minus n. Now this rule is very easy to understand. Okay, let me show you. And it's actually derived from the multiplication rule. If you have a raised to the power of m divided by, or let's say, let me use stroke, all over a raised to the power of n. What you're just looking at is that's a 1 all over this, so you can write it as a raised to the power of m raised to the power of m times 1 over a raised to the power of n. So this is now bringing out division, and we know that 1 over a raised to the power of n will be equal to a raised to the power of minus n. That is a raised to the power of n times a raised to the power of minus n. Then if we apply the rule of multiplication, we have a raised to the power of m minus n. So that is the simple thing about the multiplication rule, or rather the subtraction rule. So the next rule we'll be looking at is the identity rule. This rule is very simple. A raised to the power of 1 is equal to A. Any number, just take note that any number raised to the power of 1 is going to give you that number. Any number at all raised to the power of 1 is going to give you that number. Then look at the next rule, which is zero power rule. You just have to take note that any number raised to the power of 0 is equal to 1. No matter the number, whether big, small, negative, as long as it's raised to the power of 0, it should give you 1. Then the next rule is the negative power rule. We saw this rule when we talked about the subtraction rule, where we had that 1 all over a raised to the power of n is equal to a raised to the power of minus n. So just reverting it, that's what this rule represents. That you have a raised to the power of minus n is equal to 1 all over a raised to the power of n. Then the next rule we'll be looking at is the fractional power rule, where we have that a raised to the power of 1 over n is equal to the nth root of a, meaning 2 raised to the power of 1 over 2 is equal to the square root of 2. Or we have 2 raised to the power of 1 over 3 is equal to the cube root of 2, and so on and so forth. The second now is this rule. This rule in fraction is a fractional power rule, but it's actually a combination of two rules. So the first is actually using this rule. But the second is actually a rule that will be discussed next. So just take note that a raised to the power of m all over n is equal to the nth root of a raised to the power of m, or the nth root all in brackets raised to the power of m. This is what I'm going to use to show you after I talk about the next rule. So the next rule is power multiplication. Power multiplication rule says that a raised to the power of m raised to the power of n is equal to a raised to the power of mn. So forget the way it's written. It's a raised to the power of m, a raised to the power of n raised to the power of n. That is how it's supposed to be. Raised to the power of n, actually, not the way it's written, but we just write it that for simplification. So if you have 2 raised to the power of 2 raised to the power of 3, so just like this, it will be equal to 2 raised to the power of 2 times 3, which is 6. And we also know that 2 squared is what? 4. And 4 raised to the power of 3 is equal to 48. By 2 raised to the power of 6 is equal to 48. So we see how authentic the rule is. Then, going back to this rule, the second rule, this fractional power rule, we have that a raised to the power of n, or raised to the power of 1 all over n, is equal to, then applying this rule, we then have it's equal to the nth root of a raised to the power of n. So you see how we use the power multiplication rule here to form the second rule of the fractional power. Looking at this second one, we have that a raised to the power of 1 over n, or raised to the power of n, is equal to what? A, the nth root of a, which is this first rule, the nth root of a, or raised to the power of n. That's where we derive this rule. So see how easy the rule goes. Then we look at the last rule, which is the distribution of power rule. In this distribution of power rule, let's take our minds back to the multiplication rule where we made a statement there. Okay, here we said that 2 times 2 raised to the power of 2 times 3 raised to the power of 2 is not equal to 2 plus 3 raised to the power of 2. So adding basis does not apply here. It's rule 8 now that applies here, which is the last rule we are looking at, and it's actually what we used here, which is if you say 2 raised to the power of 2 times 3 raised to the power of 2 is equal to what? 2 times 3, or raised to the power of 2, which is this distribution of power, which says AB raised to the power of n is equal to A raised to the power of n, A raised to the power of n. So you see how this rule applies. So this is the last rule, and here are some questions I'll be giving you to solve, some solved examples. I'll give you some questions. So after the first set of examples I gave, then you try solving the remaining examples. In this first set of examples I'm giving, you have to pause this video and look at them very well, and the steps to follow, indicating the rule we use in each case, so that you know how to tackle the questions. Then you can chat me up on the contact that initially raised at the beginning of this video for you to be able to understand better if you don't know like what to solve. Then after this video, I'll put my books, the books that the document that actually contains this video, I'll put it behind. Okay, so enjoy.